In this video, we will sniff some network traffic in the industrial control system. When devices talk to each other over a network, we usually think of them addressing each other by their IP address. But in actuality, at the lowest level, they need to know each other's media access control or MAC address. Unlike some OT labs, graphics simulates layer 2 of the network as well, giving each device its own MAC address for added realism. So there is a scheme that involves a thing called the Address Resolution Protocol, or ARP, to map IP addresses to MAC addresses. The ARP protocol has no built-in authentication mechanisms, and without authentication, you can't verify the legitimacy of ARP messages. This leads many networks to be open to a type of attack called ARP spoofing. ARP spoofing allows an attacker to pretend to be another device on the network so that they can intercept messages meant for that device. In a previous video, we scanned and found that there was a human-machine interface at the IP address 192.168.90.107. In this video, we're going to see how easy it is to pretend to be that human-machine interface and intercept and sniff traffic intended for it. First, from the dashboard, open the attacker workstation. From there, open a new terminal. Just to make sure that we are doing this spoofing and sniffing on the correct network interface, first run the command ifconfig, and then find which interface is connected to IP address 192.168.whatever. The command to run an ARP spoofing attack is simply called ARP spoof, and it usually needs administrative privileges to operate correctly, so type in sudo ARP spoof and then -i, and then the name of the appropriate network interface that we just found, and then type in the IP address that you want to spoof. In this case, let's use 192.168.90.107, which is the IP address that we found in a previous video to likely belong to the human-machine interface. Now that we're ARP spoofing to pretend to be at this IP address, we should be able to sniff the traffic that's coming to and from this address. A great tool for sniffing traffic is called Wireshark, and it comes built in with Kali. So open a new terminal and then run sudo Wireshark. Once Wireshark opens, double-click on the appropriate network interface to start capturing traffic. There's going to be a lot of traffic, and the first thing we want to do is just to verify that we are ARP spoofing successfully. Let's type in ARP on the filter bar at the top and hit enter. And then we should see network traffic that shows that we are sending a message that says, hey, 192.168.90.107 is at this MAC address, and that MAC address is our MAC address, not the actual correct MAC address of the human-machine interface. In a previous video, we found that many of the devices in this network were communicating using the Modbus network protocol. Wireshark has a filter built in that can filter only for Modbus traffic, so let's try this now by going up to the display filter bar and changing ARP to Modbus. We can see some interesting stuff here. We can see that a device at 192.168.95.2 is continually responding to read requests from the HMI. From this information, combined with what we found when scanning, we can piece together that probably what is happening here is that the human-machine interface is reading from the input registers and coils of the PLC, and the PLC is the device at .95.2. If you'd like, you can double-click on any of these packets to inspect them, and you can expand the Modbus section to look at what actual values are being encoded in these packets, and try to figure out how these values map to the physical state of the industrial control system. Sometimes operators will interact with the human-machine interface, and when we're sniffing and spoofing like this, we may be able to catch the network packets that result from that, and we could possibly reverse engineer them or replay them to take control of the industrial control system as we want as an attacker. For an example of this, let's pretend we're an operator interacting with the HMI and see what we can see from the attacker point of view later. Go back to your dashboard tab and open the Defender workstation. From there, open a web browser and navigate to the URL 192.168.90.107, which is the IP address of the HMI as we've discussed, and then put a colon and then 8080, because when scanning previously, we found that port 8080 was open on this IP, and port 8080 is usually used for web interfaces for things when port 80 is not available. This SCADA LTS HMI uses the default credentials, which are admin for the user ID and admin for the password. Go to the graphical view by clicking on the little icon at the top left that says Graphical Views. You'll notice that there is a flashing button that says Running underneath it. An operator can press this button to stop the process. And we're going to do this now just to see what that looks like. So click on Running. And the button will now say Stopped. And if you go back to the dashboard and look at the visualization, you'll see that we've put ourselves in a state where the purge and the product are flowing out of the reactor vessel, but nothing is being pumped in to create any more product. Let's go back to the Defender workstation tab and click Stopped again to restart the process. Now let's see if we were able to intercept what that command did as far as network traffic. So go back to the Attacker workstation tab and go back to Wireshark and look, and you can maybe scan and see if you see anything that is different than the previous packets we were seeing. And you can see that there was a write single command packet that happened. So double click on that to open it. And you can see, if you expand the Modbus section, what exact data is being sent to either start or stop the process. We'll stop here for this video, but on your own, consider how we could use the information that we were able to sniff to possibly forge a packet with SCAPI or PyModbus that could potentially permanently shut down the chemical plant process.